Welcome back to class, everybody. Today's topic is going to be 1.2.3, what can go in, what can come out. So again, the distance learning target will be by the end of this lesson, you should be able to describe the domain and range of a function or a graph. So these are two new words right here, so make sure you guys write them down somewhere. Again, these notes are going to be available for you. You can either download them as a PDF format. You can also pretty much use it. Uh, Download a copy of this on your computer, and if you can have a way to write on it, that would be awesome. If not, it's perfectly fine. You can also just create your own notes and just follow along, right? So, first question right here. So, domain and range is again, it's something that we do talk about a lot in mathematics when we're just describing something. Primarily, domain and range is what we use when we're describing, for example, like a motion. Like if you guys are driving in your car, it's called miles per hour. So, for example, right there, you're using time to measure distance. So the domain of that would be pretty much the time, and then the range would be like, for example, the distance you've traveled. So it's rates. So we're measuring a rate in that case, which is miles per hour. So we're gonna pretty much like this see what the basics of domain and range are of a function or a graph. So we're gonna start off today with a graph. So examine the graph at right. Use it to estimate when what's y when x equals -4, what's y when x equals 1, and then what's y when x equals 4. In this relationship is a function, and then y or y not. So let's start talking about by finding the first value. So what is the value of y when x equals -4? Okay, so if you guys trace again, remember that if you're reading the graph, we're going by ones on the graph. You can see like the -4 is already marked there for you guys. So if it helps, you can start labeling these -1, -2, -3, and -4. So what would be the value of y when x is equal -4? So if you trace your graph, you go forward to the left, and then you go, how much are you guys going to go down to get to negative? So what would be the value of y there? So in this case, we can assume it's approximately negative 3.7. Those symbols that you guys, those squiggly lines right there, that means approximately. So when you see those squiggly lines, where it's an estimation of the value, it's not the exact value. All right. Okay, and then let's see what happens when x equals +1. So now let's look at x. So we're starting at our center, and then we move 1 to the right, and then we're going to end up where? What's the y value there? So when x equals 1, y equals what? And here we see it's -3. All right. And then let's see, but if you notice, like we do travel 3 down, but I also noticed that the graph, if I go up, it also crosses right there. So an easy way to do this is like how many values at 1, you can draw a vertical line there. And if you notice, it hit 2 times. So here and here. So when x equals 1, it just not only equals -3, it also equals +2. So y equals +2. All right. And then let's see what happens when x equals +4. So when x equals +4, again, go forward to the right, starting off from the center. And then you're going to let's draw a vertical line there so we see how many times it intercepts. So it has 1, 2, and then 3 times right there. So here, if you notice, when x equals 4, then we have 1, 2, 3 different values of y. So let's find those. So when x equals 4, y equals what on the first one? It looks like about 3 points something, let's say 3.2. So again, squiggly because it's an approximation. And then y equals on the second one, that one hits it on 0 right there. So y equals 0. And then as we go down, we go 1, 2 down, and then a little bit less than half. So let's say that's about 2.3. So y equals 2.3. And now, do you think this function is a relationship? So just y or y not? And then one of the easiest things you guys can use is, if you guys remember from before, we determined that we can use a vertical line test So if we draw a vertical line on any part of the graph, does it intersect in more than one point? So if I just draw it right there, you notice it intersects at exactly 1, 2, 3 points, right? So that would be like pushing one button for the soda and then you getting like 3 different results back. So it's not consistent. So you don't know where it's going to go. Okay. So like, let's say you picked a certain flavor and then you get a different one. And then you're like, okay, I maybe get the same flavor. Then it doesn't happen. So it just goes random. So you don't know where it's going to end up. So in this case, we can say that this function is not, this relationship is not a function. And then pretty much you can wrap it up by saying that because it doesn't pass the vertical line test, right? Because the graph doesn't pass the vertical line test. All right. So let's look at our next question right there. Examine the function shown at right. So they want us to calculate f of -3, f of 0, and f of 2. They also want us to calculate f of 3 and see what happens. And are there any other inputs that cannot be evaluated by this function? So remember, inputs are values that go in, right? And then, in other words, are there any values that actually cannot be? Okay, so that is something that cannot. And then they're throwing again the question domain. So let's start off with the first one. Let's look for f of -3. So if a -3 goes into the function machine right here, we have f of -3. And then we plug it in, so we're going to be 6 over. And remember, wherever we see it next, we're going to replace it with the value that they're telling us to input. So in this case, it's -3. All right. So from there, we're going to move on. And this is going to be 6 over. If you have two negatives, so this is going to be -3 minus 3. You pretty much add them up. You keep the negative, you get -6. And then in this case, we're going to say that f of -3 equals +6 divided by -6 is -1. All right. Now let's see what happens if we put in a 0 into the machine, right? So now 0 is next. So we go f of 0. That's going to be equal to, we're going to say 6 over, again, 0 minus 3. 0 minus 3 is, again, you still have -3. So that's equal to 6 divided by -3. A positive divided by a negative, again, is another negative. And in this case, it's -2, I'm sorry. So we're going to say f of 0 equals -2. And then let's see what happens when we insert f of 2. So let's do f of 2. So that's the next value that's going to go in. So 2 goes in there. All right. So f of 2, that's equal to 6 divided by, again, substitute where you see an x. That's going to be 2 minus 3. And that's equal to 6 over, in this case, 2 minus 3 is -1. And then that's going to give us -6. So we're going to say that f of 2 is -6. And those are the three values that we found in this function. So let's see what happens when we plug in 3. So what happens if you plug in 3, which is our next number right there? So let's do right here. So f of 3 equals 6 over 3 minus 3. So that would be 6 over 0. So what happens when you guys divide by 0? So a lot of people think that your answer is, again, 0. No, that's not true. So if you think about it, the 0, when we do division, is that when you have to multiply the number in the bottom by to get the number on top. And in this case, if we notice, if we multiply any number times 0, like 0 times 3 gives us 0, right? It's not equal to 6. If we multiply times 4, it gives us 0 again. If we multiply times any number, it's always 0, right? So in this case, since we cannot find which value we're going to be able to multiply 0 by to get 6, we call this the undefined. So 6 divided by 0 is what we call undefined. All right. So this is when you have pretty much any number except for 0 over 0. All right. Okay. That's pretty much what happens right there. So do you think there's any other inputs that cannot be evaluated by this function? In other words, are there any other values that x cannot be? Explain how you know. So you think we can plug in any number in here and it's going to be pretty much, we're always going to get a number back? So what do you think? So for sure, the only number that we found so far that can be plugged in there is positive 3 because we get the undefined. Do you think there's other values that would make that undefined? So in this case, there is no other values that would make it undefined. So we can say they are the only inputs that makes the function undefined is 3. All right. So the set collection of numbers that can be used for x in a function and still get an output is called the domain. So pretty much any number that we call it the input, right? What we've been calling inputs, we can also call it the domain of the function. So here, that is, a domain is a description of a list of all the possible x values for the function. Describe the domain of f of x equals 6 over x minus 3. So pretty much the domain would be where is the function defined, all right? So we can say the function is defined across, so the function is defined across all values except at x equals 3. Except at x equals 3. All right. What other types of functions have you looked at thus far in this course and previous courses that have limited domains? You guys think there's another one? And then how were they limited? All right. So it depends what type of functions you remember here. You could be looking at pretty much, since this is a beginning course, right? You guys have seen the straight lines, maybe the exponential functions. All right. You also seen the parabolas, right? And then there's also, so again, that's a line. That's the exponential. And then the parabolas. Right. And then you also have a cubic function. You guys will get to explore these different functions later on in the course.